All right, for today's lesson, we are going to be talking about dependent events. So I am on page 777. If we read the definition, it says if an outcome of one event affects the outcome of another event, the events are called dependent events. For example, you have a bag with blue and green marbles. You pick one marble, don't replace it, and pick another. So this is kind of related to the activity when we picked one counter out, we left it out, and then we picked a second one. That first probability changed the probability of our second one. Okay, so let's go ahead and turn the page and see some examples. All right, so there are 4 oranges, 7 bananas, 5 apples in a fruit basket. Inacio selects a piece of fruit at random, and Terrence selects a piece of fruit at random. Find the probability that the 2 apples are chosen. Okay, well, first of all, we have to figure out how many different fruits we have to choose from. So we have 4 oranges, 7 bananas, and 5 apples. So we have 4 plus 7 plus 5 total fruit, which would give me a total of 16. Okay, so I have 16 total fruit to choose from. On Inacio, he picks first. He has 5 apples in the basket to choose from, times, because this is our fundamental counting principle, Terrence now is selecting. So if Inacio picked an apple out of the basket, we only have 15 fruits left in the basket, and then there's only 4 apple choices left. Therefore, our probability would change to 4 out of 15. When we could cross-reduce, this would give me 4, this would give me 1. I would multiply. 1 times 1 is 1, 4 times 3 is 12. So our probability that 2 apples are chosen are 1/12. I want you to pause the video and go ahead and try got it B and C. All right, for got it B. Again, we still have 16 total fruit to start with, okay? If I have 7 bananas to start with, my probability of the first draw would be 7 out of 16 total fruit. Okay, but now that I've picked out one of the bananas, I have 6 bananas left in the basket and 15 total fruit. Okay, I could cross-reduce on this one. Divide by 2, I get 3 over 8. And then I can multiply straight across. 7 times, I could cross-reduce here again. So 15 becomes a 5, the 3 becomes a 1. 7 times 1 is 7, 8 times 5 is 40. So my probability of 2 bananas is 7/40. Okay, and then my last example, the probability of orange, then an apple. Okay, so I still have 16 total fruit on my first draw. I have 4 oranges to choose from, times, if I pick one of the oranges out, I'm left with 15 total fruit, but since my first draw was an orange, I still have 5 apples. Okay, so how can I simplify?
Up and down.
Up and down, yes. So I would divide the 4 and the 16 by 4. So 4 divided by 4 is
4.
16 divided by 4 is
4.
Okay, where else could I reduce?
5.
Okay, divide by 5 divided by 5 is
1.
15 divided by 5 is
3.
Okay, so now I have 1 times 1, which is
5.
4 times 3, which is
12.
12. Somebody type that in a calculator and tell me what the decimal is.
0.0808.
Round to the nearest hundredth for me.
0.84. 83. Wait, 0.8. Make it fly. Ready? Put your hand out.
Okay, which would be the same as 8%. Perfect.